Good evening, students. So we were discussing about D and F block elements. So we have completed transition elements, right? Then we have seen some of the important compounds in the last class. Then we had started with inner transition elements. So inner transition elements, we have studied about lanthanides, right? So today we are going to start about actinoids. In the last class, we have already studied about the general characteristics about lanthanides, right? What is the general electronic configuration? Then we have seen about the atomic and ionic size, how it decreases. Okay, we have studied about what is lanthanide contraction. Then we have seen how is the reaction, chemical reactivity of the lanthanide metal. Okay, then what are Misch metals, right? So we have studied about the oxidation state, the various oxidation state, right? Then we have studied about the physical properties, then formation of colored compounds, right? Then the chemical properties also we have discussed. Then we had discussed about the uses of lanthanides, right? So today we are going to study about actinoids. So what are actinoids? Yes. What are actinoids? So actinides are the series of 15th metal elements with atomic number from 89 to 103. Okay. So 289 to 103. So from 89, atomic number 89 to 103, the name of the series come from actinium. So the series, it starts from the element actinium, the element that marks the beginning of the series. So actinium is the first element which marks the beginning of the series. Okay. All the members of the series have similar chemical properties. So these members, so all the elements which are belonging to this particular series, they will be having, they will show similar chemical properties, right? So we'll see which are the different elements which are present. So which are the different elements which are present in the actinoid series. Okay, so it starts from the element actinium. So as we have discussed, it starts from the first element that is actinium. So I'll write it as element, then atomic number, okay, and electronic configuration. Electronic configuration. So when we write, so it will be like this. Okay. So what is the element? It starts from actinium, AC. So I'll be writing the symbols. Okay, actinium. Then next is thorium. So thorium is TH. Okay. Then protactium. Okay. So protactium, it is Pa. Then is uranium. Uranium is U. Then comes neptunium. So neptunium is Np. Okay, so the symbol of the element neptunium is Np. Then comes plutonium. Plutonium is Pu. Then comes americium. Okay, so americium, it is Am. Then next element is curium. So it is Cm. Okay, then the next element is berkelium. Okay, so it is Bk. Then next is californium. So californium is Cf. Then comes einsteinium. Einsteinium is Es. Okay. Then I'll write the further here. So then comes what? I'll write it here. So for einsteinium, then comes fermium. So it is Fm. Then comes mendelevium. Okay, mendelevium. Then comes nobelium. So nobelium is No. Then come lawrencium. Lawrencium is Lr. So these are the symbols. So I'm writing the symbols of this elements. Okay. So it starts from actinium. So the series of the actinoids, it starts from the first element, that is actinium. So what is the atomic number? Okay. So atomic, it starts from actinium, and the last element of the actinide series is lawrencium. Okay. So it starts from the atomic number 89. So it starts from the atomic number 89 and it ends with the atomic number 103. Okay, it ends with the atomic number 103. So the electronic configuration, it starts from radon, okay, 6314s2 to the last 103. It is for radon 5f14, okay, 6d1 and 7s2. So this is the electronic configuration. So in between you can just go and fill. Okay, so thorium, it will be 90. This is proactium, will be 91. Uranium is 92. Neptunium is 93. Then plutonium is 94. Americium is am, that is 95. Then curium is 96. Okay, so and so on. So these are the atomic number and electronic configuration. So it starts with actinium and it ends with lawrencium. Okay, so what will be the general electronic configuration then? What will be the general electronic configuration? So the general electronic configuration of actinide series, it is, okay, it is radon 5f 1 to 14, then 6d 0 to 1, okay, and 7s2. So this is the general electronic configuration of actinoid. So this is the first property. Okay, so the first property, that is electronic configuration, their general electronic configuration is radon 5f 1 to 14, 60, 0 to 1, and 7s2. Okay, then next is ionic size. So next, when we are discussing about ionic size, so you know that gradually the ionic size, it decreases. Okay, so there will be decrease in atomic and ionic size of actinoids. So gradually means what? Slowly. Okay, slowly the atomic and the ionic size, it goes on slowly, gradually it goes on decreasing. That is the size of the actinoids. Why? It is due to poor shielding of one 5f electron by other. Okay, so it is due to poor shielding of 5f electrons. So here you can see the third point. So there will be gradual decrease in the atomic and ionic radii, that is the size of the actinoids. It is due to poor shielding of one of the 5f electrons, okay, by other, is known as the actinoid contraction. So this gradual decrease of actinoids, size in the actinoids, is due to what? It is called as actinoid contraction. It is called as what? It is called as actinoid contraction. Okay. So, however, this contraction is greater from element to element as compared to lanthanoid. So, as compared to lanthanoid, here the contraction is greater. Okay, the contraction here seen is greater as compared to that in the case of actinoids. So, this is about your what you can say, ionic size. So, when you're talking about ionic size, so because of the poor shielding of this one of the 5f electron, so because of this, there will be contraction. Okay, so the contraction will be greater. So this is about ionic size. Next is oxidation state. Okay, so next is oxidation state. So actinoids, they show a variable oxidation state. Variable oxidation state means what? They will show different oxidation state. Okay, because the energy difference between 5f 6d and 7s orbital is very small, and hence all the electrons are used in bonding. Okay, so because what happens, because of the energy difference, because the energy difference is more in 5f, so 5f orbitals are different, 6d orbitals are different, and 7s orbitals are different. All are of different orbitals, right? S orbital, d orbital, f orbital. So the energy difference will be more. So because of this energy difference, what will happen? They will show it will have very small, and all the electrons are used for bonding. Okay, so the energy difference between this, what is that, 5f, 6d and 7s is very small, and thus all the electrons are used in bonding. Okay, actinoids, they have the generally the actinoids, they will show +3 oxidation state. So generally they will show what type of oxidation state? They will show +3 oxidation state. So generally, okay. And in their series, the maximum oxidation state increases from +4, okay, to +5 and +6. So the higher oxidation state shown by the actinoids is +4, +5 and +6. So it will go on increasing. So the maximum oxidation state increases from +4, +5 and +6 and +7. Okay, but again it decreases. So for Neptunian, okay, that is Neptunium, it shows the highest, that is +7. So Neptunium, it shows the highest oxidation state, that is +7, and again it decreases. So what happens? The oxidation state, it goes on decreases. So next is actinoids. So actinoids, they are highly reactive, silvery white in appearance. Okay. So these elements, actinoids elements, they are highly reactive metals, and they are silvery white. The color, they look as a silvery white, and in their appearance. Okay. So the binding energies of 5f electrons are lower. Then due to lower binding energies, they show higher oxidation state. Okay. So the higher oxidation shown is +4, +5 and +6. Then 5f electrons, they have poor shielding effect. So this is called as actinoid contraction. So most of their ions are colored. Okay. So uranium +3 is red, uranium +4 is green, and uranium UO 22 plus, it is yellow in color. Okay. So they have much greater tendency to form complexes. So actinoids also, they have the ability to form complexes. All actinoids are radioactive. So here the actinoids, they are radioactive. Okay. Then their compounds are more basic. So their compounds are more basic. Then they have greater tendency to form complexes. Their compounds are more basic. So here the compounds formed are more basic. Okay. Then they form oxocations. They form oxocations. Oxocation means what? They form complex with oxygen, that is uranium O2 plus 2, uranium O plus. Okay. So these are some of the complexes. So these are some of the general properties of actinoids. So next we'll go for, so this is the general configuration as we have discussed already. So actinoids, they exhibit a range of oxidation state due to comparable energies. So they have comparable energy means similar energies. Small energy differences there between 5f, 6d and 7s orbitals. So generally the oxidation state of actinoids is +7. So this we have already discussed. Then the next is all actinoids are strong reducing agents and very reactive. So all the actinoids, they are strong reducing agents and they are very reactive. Actinoids also react with oxygen, halogen, hydrogen and sulfur like lanthanoids. Okay. So actinoids also, they react with oxygen, halogen, hydrogen, sulfur and like lanthanoids. Okay. So as we have seen the chemical reactions with lanthanoids, how they form the complexes, okay, how they form the compounds with oxygen, halogen, hydrogen, sulfur. So like lanthanoids, actinoids also react. Actinoids are radioactive in nature and therefore it is very difficult to study their chemical nature. So now we'll see the difference between lanthanoids and actinoids. Okay. So what are lanthanoids? So lanthanoids are the chemical elements which are found in the periodic table F block of the lanthanoid series. So lanthanoids, where they are found? They are found in the F block, okay, of the lanthanoid series. Their atomic number, it ranges from 57 to 71, right? Then actinoids. So these are the chemical elements which are found in the actinoid series of the F block in the periodic table, and their atomic number, it ranges from 89 to 103. So this is the main difference. So both are from F block element, but these are lanthanoids are from lanthanide series, actinoids are from actinide series. Okay. So lanthanoids, the atomic number starts from 57 to 71. Actinoids, their atomic number start from 89 to 103. They are so lanthanoids, next difference, they are from the sixth period and belong to the third transition series, making up the first inner transition series. So they are called as the inner transition series. And actinoids, they are from the seventh period and belong to the fourth transition series. So this is called as the second inner transition series. Okay. Then in lanthanoids, the valence electrons are present in 4f orbital. So the last electron, it will occupy where? It will occupy the 4f orbital. And in actinoids, the valence electrons, they are present in the 5f orbital. Okay. Then the binding energy of 4f orbitals is greater. And in actinoids, the binding energy of 5f orbital is less. Then lanthanoids, they will show +3 oxidation state, and they will show +2 as well as +4 oxidation state. So they will show variable oxidation state. And in actinoids, so commonly, generally, they will show +3 oxidation state. Also, they will show higher oxidation state like +4, +5, +6, and +7. Okay. Then lanthanoids, most of the ions, they are colorless. In lanthanoids, the ions are colorless. In actinoids, most of the ions, they are colored. Then lanthanoids, their tendency to form complex ions is less. So the complex formation in case of lanthanoids is very less. In actinoids, their tendency to form complex ions is greater. Okay, it is much greater. Then their compounds are less basic than actinoids. So in actinoids, the compounds are very less basic. In actinoids, they have more basic compound than lanthanoids. Okay. So actinoids, the compounds are more basic. In lanthanoids, the compounds are less basic. Then they are non-radioactive except for promethium. So all the lanthanoids, they are non-radioactive. Only one element is radioactive, that is promethium. And in actinoids, all the elements are radioactive. So these are the major differences. Okay. Please make a note of these differences, very important differences. Okay. So and lanthanoids and actinoid series. So these are some of the major differences between lanthanoids and actinoid series. Okay. So so we'll go for the next. So next is the application of D and F block elements. So what are the applications? Okay, where it is used, D and F block elements, iron and its amalgam, steel are utilized broadly in the development industries. Okay. Titanium is a part of the manufacture of airship and spaceship. So titanium, it is used in the manufacture of airship and spaceship. Then tungsten, it comes in use in making of electrical fibers. So in making the electrical wires or fibers, tungsten, it is used. Then manganese dioxide, it comes in use as a part of dry battery cells. So in the preparation of dry battery cell means what? Which you use for remote control, right? For remotes, for your TV remotes, right? For toys, so, right? So for that, which you use the battery. So those are called as dry battery cells, right? So, so in that dry battery cells, what is used? Magnesium dioxide is the part of that dry battery cells. Next is zinc comes in use as a negative anode in fixed dry batteries. So in the dry batteries again, zinc is acting as a negative anode. Okay, negative anode in the dry batteries. Then niobium composites are perfect as a part of fly motors. So as a part of fly motors, niobium composites are present. So these are some of the application. So next, tantalum comes into use to make expository weights. Okay. Then silver bromide comes into use as a part of photography. So in the part photography, okay, for photographic films, okay, so silver bromide, it is used. Then many D block or transition metals and their compounds find their use as impurities in the chemical reaction. Then palladium chloride comes into use in the Walker process of oxidation of ethane to ethanol. So these are some of the applications where we are using D and F block elements. So iron, it comes in use in the production of ammonia in Haber's process. So Haber's process is a process wherein you are making use of nitrogen. Okay. So nitrogen and hydrogen, what you're going to do, you're going to pass hydrogen gas over the nitrogen gas, and you're making use of iron catalyst there. So we are making use in the production of ammonia. Then next is Ziegler-Natta. So Ziegler-Natta is another catalyst which is very important in making polythene bags, right? Polythene plastic bags. So from ethene to polythene, when you're converting, so that is a polymerization reaction. What do you mean by polymerization reaction? It is a chain reaction. So from a small monomer, you are making up a polymer. Okay. So the monomer which is used in polymerization process is ethene. So we are converting ethene into polythene. So the catalyst means what? It is what? It is fastening the reaction. Okay. So the reaction rate will be fastened. So Ziegler-Natta is the complex. So the name is Ziegler-Natta, and it consists of what? Trimethyl aluminum and titanium tetrachloride. So make a note of this. Very important. Okay. So this question can be asked in polymer chapter. So polymer chapter, that is Ziegler-Natta. What is Ziegler-Natta? What is the composition of Ziegler-Natta? It is trimethyl aluminum and titanium tetrachloride. Okay. So make a note of this. What is Ziegler-Natta? What is the composition of Ziegler-Natta? It is trimethyl aluminum and titanium tetrachloride. Okay. So where it is used? It is used in polymerization. That is from ethene to polythene. You're converting your ethene. Ethene is a small molecule monomer to polythene. Okay. Okay. So it is a polymerization reaction. So these are some of the applications of, so these were some of the application on D and F block elements. Next is uses of F block elements. Okay, lanthanoid alloys, that is mish metals. You know what are lanthanoid alloys called as? Lanthanoid alloys are called as mish metals. So these mish metals utilized for the creation of instrumental steels and heat resistant. So it is used for the creation of instrumental steels, okay, and heat resistance. Then carbages, borides and nitrides. Okay, carbides, borides and nitrides of lanthanoids come in use at refractories. Okay, refractories means what? They are the huge surface, okay, wherein the temperature in the refractories will be more. For suppose making of bangles, okay, you know, bangle making, it requires more amount of heat, right? So same, refractories means huge surfaces, okay, big surfaces wherein the temperature is controlled there. So carbides, borides and nitrides of lanthanides come in use as refractories. So in making of a refractories. Next is lanthanide oxides come in use in cleaning glass as abrasive. Okay. So lanthanide oxide, it is used in cleaning the glass as abrasive. So these were some of the uh, uses and what you can say applications of D and F block element. Okay. So is it clear? So these applications are not so important. So the properties you need to remember. Okay. So the properties, what are mish metals? What is the oxidation state? How are the chemical reactions? What are the differences? What are the main differences? What is lanthanide contraction? What is actinide contractions? What are general electronic configuration of lanthanide series, actinoid series? Okay. Then about transition elements, we have seen the important compounds, both the compounds. Okay. Two compounds, their structure. Okay. Then we have seen about the transition series, the different properties. Okay. Alloy formation, then color complex, color compounds, then magnetic property. Okay. Non-psychometric compounds. So these are some of the important concepts from D and F block elements. So by this, we have completed the synopsis of D and F block elements. Okay. So any doubts? Any doubts from the synopsis part? Any doubts? If you have any doubts, you can ask me. Yes, any doubts from the synopsis part? I'll just move the slides. If you have any doubts, you can ask me. Question MCQs, I'll be starting in the next session. Okay. MCQs about D and F block elements. I'll be starting in the next section. So this is all theoretical part. Okay. So there won't be any problems. So solution chapter we have. So there were some formulas. So using that formulas and all you have to solve. Then haloalkanes, haloarenes. So these are all reaction based questions. Now D and F block elements, so you'll be having theory. So it is all theory part. So uh, today, so I'll be giving you a small task. You have to just go through the D and F block, whatever have been taught. So next class, entirely one class I'll take for the MCQs because it is all theoretical part. Okay, because it is all theoretical part, so we can finish up the MCQs fast. So if you have any doubts, you can ask me. I'll just move the slides. Okay, so just go through the slides. Many students have attended today. Okay, so just I'll move the slides. You can just so this is about metallic property. So these were some of the general properties of transition elements. So metallic property, the reducing power of transition element, then density. Then we have discussed about melting and boiling point, then formation of colored compounds, and then we have discussed about alloy formation, then color properties. Okay, why transition elements show color. Then we have discussed about magnetic property. Magnetic property is very important. Okay, we have studied how to calculate the magnetic moments also. What is Bohr magnetism, right? Then we have discussed about non-psychometric compounds. Then we have seen some of the important compounds of transition element about potassium dichromate. So which is the overuse? It is ferrochrome or chromate. Right. Then we have discussed about the preparation. Next compound which we had seen was about potassium permanganate. So the ore which is used for the preparation of potassium permanganate is pyrolusite. So commercial preparation also we have seen. Then we have discussed about the properties. We have seen the structure. What is the uses? Then in the last class, we had discussed about the inner transition elements, that is F block elements. So it consists of two series, Lanthanoid series, which we have discussed in the last class, Actinoid series, we have discussed today. So these are the general characteristics. What is the chemical reaction? Okay, what are mixed metals? Then today's class, we have discussed about the general characteristics of actinoids. What are the properties? Then we have seen general properties, right? Then we have seen the differences between lanthanoids and actinoids. Then we have seen the application of D and F block elements, right? Then we have seen the uses of F block elements and so. Okay. So if there are no doubts, any doubts? No one is answering. That means there are no doubts. I hope so. Yes. So we'll end the session here. If you don't have any doubts. So next class, okay, next class we will do MCQs on DNF block elements. After DNF block elements, which chapter you want me to do? Yes, after DNF block elements, which chapter you want me to do? Please, somebody answer, or else you can just type in the chat box. No problem. So it will be helpful for you also. It will be helpful for me also, because you'll be having idea. Okay, whatever has been taught. So if we go in that flow only, so it will be good for you also. So it will be like brushing up the things. Yes. After DNF block, which chapter you want me to do? Okay, electrochemistry. Others, is it okay if I start with electrochemistry? Okay, Anvita has messaged as alcohols. I'll just make a note. So back to back, I can take that. Okay. Yes. Others. Alcohols. Priyanka has messaged alcohols. Others. There are 6 members. I want 6. Everybody has to tell me. Okay, electrochemistry. Now give me electrochemistry. Okay, so what we'll do first, I'll take electrochemistry because majority have told as electrochemistry. Okay, so 1, 2, 1, 2. Okay, so first I'll do electrochemistry. Then next chapter I'll take alcohols. Is it okay? So next chapter I'll take alcohols. So first we'll complete electrochemistry. Then we'll go for alcohols. Is it fine, or first we'll do alcohols? You all only tell me. I am fine with anything. Okay, fine then. Okay then, so I shall end the session here. Okay, so we'll meet in the next class. So please go through the synopsis of D and F block elements. So in the next chapter, next class, we'll be solving some of the MCQs based on D and F block elements. And after that, we'll start with electrochemistry followed by alcohol chapter. Okay, so thank you. I'll end the session here. So I'll meet you in the next class. Thank you.